Good morning, students. Now here we are going to start with the second PU syllabus, and the topic, as you have already know, that I am going to start is continuity. So continuity is the chapter in differentiation that I am going to start with initially. Now let me tell you a brief introduction about this chapter. Now, last year you have studied functions, and you know how do you denote a function. A function is denoted generally by y is equals to f of x, where x and y are known as the variables, and here x is known as the independent variable and y is known as the dependent variable. X is known to be the independent variable and y is known to be the dependent variable. Now remember that if I want to explain you continuity first graphically. I will be showing you graphically. Now let me consider the graph of this function y is equals to f of x. When I draw the graph, say from the point A to the point B in an interval, and if the graph is like this, if there is no cut in the graph, then we say that the function is continuous. And suppose the graph is in this way, so from the point A to the point B there is some cut in the graph, that is, it is not defined at the point x is equals to c, then we say that the function is discontinuous. Then we say that the function happens to be discontinuous, and we say here that the function is discontinuous at the point x is equals to c. We say that the function happens to be discontinuous at the point x is equals to c. Now this happens to be the graphical representation of how does the continuity of a function. Now here I have taken the interval. That interval may be an open interval or an closed interval. We say that it is an open interval or we say that it is a closed interval. Now remember that in case of an open interval, the end points are included, and in case of the closed interval, in case of the open interval, the end points are not included. They are not included, and in case of the closed interval, the end points are included. Now every time it is not possible for us to draw the graph of the function and check the continuity and discontinuity. So for that, what we do is we give a mathematical definition. We say that we give a mathematical definition of the continuity of a function. First we shall define the mathematical definition, First we shall define the mathematical definition of a function at any point x is equals to c in a given interval, say it may be closed interval or an open interval. First we shall define the mathematical definition at any arbitrary point. Now let y is equals to f of x be a given function, which is defined in the interval AB. Let y is equals to f of x be a function which is defined in the open interval AB. Then This function is said to be continuous at the point x is equals to c if the following conditions are satisfied. If the following conditions are satisfied. So a function y is equals to f of x is said to be continuous at the point x is equals to c if these following conditions, three conditions, I am going to give you all three conditions. If these three conditions are satisfied, then we say that the function happens to be continuous at the point x is equals to c. First, the function is defined. The function is defined at x is equals to c, that is f of c exists, that is you will be getting the value of c. Then limit of the function, that is limit, if you find it should exist, that you should get a real number. When you solve the limit of the function as extends to c, limit of the function as extends to c, you should get a real number. And the third condition is that limit of f of x as extends to c, it should be the same as f of c. Limit of f of x as extends to c should be equal to f of c. Then we say if these three conditions are satisfied, if these three conditions are satisfied, then we say that the function y is equals to f of x is said to be continuous at the point x is equals to c. This is at any one point. Then how to extend this? Then how to extend the same definition to an interval? We say that the function is continuous in an interval. We say that the function is continuous in an interval if it is continuous at every point in the interval. If it is continuous at every point in the interval, then so you have to go on checking each and every point. If it is an open interval, just leave the end points. If it is the closed interval, include those points. It should satisfy all these three conditions at each and every point. Then we say that the function is continuous in an interval. Then we are going to say that it is continuous in an interval. So this was just an introduction class. So from the next class onwards, we are going to have the problems based on this, and I will be repeating the same definition once again. Thank you.